Okay, in lesson 2.7, we're going to be talking about absolute value functions. We'll be graphing them, and let's see, this is going to relate to what we did yesterday, or in lesson 2.6. So important to keep in mind transformations when we go about graphing absolute value functions. So here's our standard parent function for an absolute value. F of x equals absolute value of x, just like y equals absolute value of x. And you see the graph below there is a v. That's because you can plug in different x's and get the same y. Like if I asked you to plug in the absolute value of 2, you would say you'd get 2. And if I told you to plug in negative 2, you would also get 2. So you get that formation of a v happening because when you plug in a negative or the opposite of a number, you get the same output, the same result. Absolute value functions have a vertex, they make a v, and it has a v in the word value. So you need to be thinking v's when you talk about absolute values. And if I told you, asked you how many solutions an absolute value problem usually gets you, you'd hold up 2 fingers, which could look like a v. So lots of v's. Most important point on absolute value is the vertex. In this case, our vertex, our bottom number, is 0, 0, the origin. So the absolute value function, parent function, has a vertex of 0, 0. Another thing we identify is the axis of symmetry. Axis of symmetry is a line you would draw that would cut the shape in half so that if you folded it, it would overlap. That's this vertical line right here. And a vertical line has the form x equals. And what does x equal? 0. All the x's are 0 there. The y's change, we're at different heights, but we're no farther left or right no matter where we're at. We're always at x is 0. Alright, so one way to graph these, well, first you got to be able to find the vertex. And once you've found the vertex, you can plug in a couple of points on each side of it to get the slope of each side of the v. So I'll talk about slope here in a second. First off, what's the vertex? Well, up above we had y equals absolute value of x, and that had a vertex of 0, 0. Now think about what we did in lesson 2.6 with the transformations. If I put a minus 3 in with the x, if you remember correctly, that tells you to actually go 3 right. And the plus 2 at the end tells you to go 2 up. Our parent function has 0, 0 for a vertex, and it also has 1, 1 on there and 2, 2. It also has negative 1, 1 and negative 2, 2. But these transformations tell me to go 3 right, and that changes the x. So I'm going to add 3 to all my x's. That would give me negative 2 plus 3 is 1, negative 1 plus 3 is 2, 3, 1 plus 3 is 4, 2 plus 3 is 5. And then we need to go 2 up on the y's, so we're just going to add 2 to the y's. 2 plus 2 is 4, 2 plus 1 is 3, 2, and then 2 plus 1 is 3 again, and then 2 plus 2 is 4. Here's where we end up. We end up having a new vertex of 3, 2, because we had to move 0, 0, 3 right and 2 up. So 3 right and 2 up is right here. And then you could graph those other points, 4, 3, 5, 4, 3, 3, and 1, 4, and you get this V shape again. Now really all you need to know is that the vertex is 3, 2, and that there's a slope. Think about the slope. The slope's kind of in front of my absolute value right here. The slope would be 1. There's nothing there, so it's like having a slope of 1. So if you can identify the vertex being 3, 2 right here, and then just go up 1, 1 right, but then you also need to go up 1, 1 left. And that gives you a point on each side. And that's another way to get the V rather than making a whole big list. Let's do a little review over here. What would the axis of symmetry be? That would be the line x equals 3. What about if I ask you the domain of this v? Well, domain goes with the x's, and x's go left and right, and I can go forever left. I can go forever right. There's no skips in the middle, no holes, no jumps, no breaks. So x could be anything. X could be all reals. So the domain is all reals. And the range is your y's. There I'm asking how far up and down can I go? Well, I can go forever up. I can go forever up left. I can go forever up right. But what I can't do is go any lower than the vertex here. And the vertex has a height of 2. So the range has to be greater than or equal to 2. So you can either put y is greater than or equal to 2, or if you do all reals is greater than or equal to 2. Either way, I'm perfectly happy with that. Let's graph this on a graphing calculator. I don't have my calculator brought up right now, so you have to ask me about that in class. Y equals 4 times the absolute value of x. Let's think about our parent function. Y equals absolute value of x. That has a vertex at 0, 0. What's 4 going to do? 4, if you remember from 2.6, is a vertical stretch of 4. And if you want to apply a vertical stretch of 4, that just means you're going to take the y and multiply it by 4. Wow, that just leaves you at 0, 0. So on this one, the vertex is at 0, 0. It doesn't move. The only way to move the vertex is to have some number in the absolute value with the x. That'll make it go left or right. And then, or a number at the end. That'll make it go up or down. So if you got an extra plus or an extra minus at the end. If you multiply, it does not move it. So here I've got 0, 0. I could make a chart and plug in 1 and 2 and -1 and -2 and see what I get up here. Just by plugging in 1, if I plug in 1, I get 4 times the absolute value of 1. Absolute value of 1 is 1. 4 times 1 is 4. This will give me 8. Otherwise, the slope is 4. Slope is 4. So I'm going to go up 4, 1 right, there's my point. I go up 4, 1 left, there's my point. And I can do it again. Draw my V. There's my absolute value graph. Y equals 4 times the absolute value of x. Next example, y equals 1/3 times the absolute value of x. Well, there's no adding and subtracting. So again, the vertex is at 0, 0. But in this case, the slope is 1/3. So I'm just going to go up 1 and over 3. Up 1 and 3 the other way, because you got two ways to go on an absolute value. You can either have a positive or a negative. And I can do that again just so I can get comfortable with my rays on each side. Notice that this absolute value graph is been kind of squished down. It's not like my parent function because that 1/3 again stands for a vertical compression. You're pushing down on something, so if you push down on something, it gets wider. Next one. This one again, no adding and subtracting. So vertex stays 0, 0. The slope's -4. So that means that I'm going to rise -4, which means go down 4, 1 right, and down 4, 1 left. Ray on that side, ray on that side. There's my function there. Review, if I asked you for domain, that'd be the x's. That thing goes forever left and right, so it'd be all reals. If I ask you for range, that's my y's, and this one's a little different than ones we've talked about before because this one goes down forever. Both left and right goes down forever, but never gets any higher than 0. So the range would be all reals less than or equal to 0. Let's review what -4 means over here, what this means. -4 means two things. The negative in front means you're going to have a reflection over the x axis. So when you negate a whole function, that means reflect it over the x, make the whole function negative. And then the 4, of course, that's a vertical stretch of 4. Those are the two things that are happening to our parent function, which again is y equals absolute value of x. Okay, well, looking at the transformations. Here I gave you a base table. I went from -3 to 3 on the left, and then I get 3 to 0, and then 0 to 3 on the right. Get rid of those, okay? We're just going to apply the transformation, so kind of review from 2-6. I would do order of operations. That would tell me to do inside first. So I'm going to deal with the 3. That plus 3 actually means go 3 left, and that, of course, affects an x-axis. So let's go 3 left of all these x's. 3 left to -3 is -6. 3 left to -2 is -5. And then we're just 3 left, -3. We just work our way down to 0. Okay? Then you need to deal with the 4 because multiply comes before subtract. So what does the 4 do? That's a vertical stretch. So that's a vertical stretch of 4. So that means I'm going to multiply the y by 4. That's how you affect something vertically. So y is going to become 12, 2 times 4 is 8, 1 times 4 is 4, 0, 4, 8, 12. Okay. Then finally we've got the -2. That also affects the y. -2 is 2 down, so you take all these and subtract 2. 10, 6, 2, -2, 2, 6, 10. So here's my new points that I use. -6, 10, -5, 6. The most important point is the vertex. And the vertex started at 0, 0, but it ended up right here at -3, -2. Now I would want you to get that -3, -2 just by looking at my initial function and saying, okay, I got to go 3 left because it's +3. I got to go 2 down. My vertex isn't affected by the 4 because when I take 4 times 0, it stays 0. Those are the only two things that really affect my vertex. So my vertex is at -3 and -2 right here. 3 left, 2 down. We could graph these points that I made on the chart over on the left. I'm just going to go ahead and use the slope, which is 4. There's my slope. So from here, slope of 4 is up 4, 1 right, and then up 4, 1 left. Up 4, 1 right, up 4, 1 left. Draw your 2 rays of your V. And you have your absolute function graph. Up above you have what's the axis symmetry. V's a little bit out of whack here. Sorry about that, but the axis symmetry would go through the vertex no matter what. It's a vertical line, so it's x equals, and what's the x of the vertex? The x of the vertex was -3. All the x's are 3 left. Right here's -3, -2. Here's -3, 0. Here's -3, 1, -3, 2, -3, 3. All the x's are -3. That's the axis of symmetry. Domain on that one would be all reals. Range would be all y's greater than or equal to -2. This one, I'm going to skip the base table. I'm just going to go ahead and identify the vertex. The vertex over here would be found by going 3 right and 4 up. So I need to take my 0, 0, which would be right here. I need to move it 3 right, 4 up, and that's my vertex. My vertex is at 3, 4. The slope is -2. The slope of -2 tells me to go down to 1 right, down to 1 left. Let's do another one for good measure on each side. There's my graph of that function. Okay, this one's tricky because you might think that I need to go 12 right, but you'd be wrong because it's not an x in there, it's a 4x. So something like this, you want to basically factor the 4 out. Think of this, you're going to do the absolute value of 4 times x minus 3. So I took 4x minus 12 and changed to 4 times the quantity x minus 3. That is the same as the absolute value of 4 times the absolute value of x minus 3 plus 6. And we all know the absolute value of 4 is 4. So although it appears this one has a vertex of 12, 6, it really truly has a vertex of 3, 6. This would be 3 right, this would be 6 up. So my 0, 0 goes 3 right, 6 up. My slope appeared to be 1, but in reality my slope is 4. So I need to go up 4, which I'm going to go off the grid here. And 1 right, and up 4, 1 left. That is a tricky one. If you have a number in front of the x, you need to get it out of there. Divide both inside terms by what's in front of the x. I think on the assignment there's a couple where you've got a fraction in front of the x. That'll be trickier yet, so we'll have to practice dividing a fraction out of an integer number. Right equation of the graph shown. Well, kind of in general, here's what we're looking at. We're going to have some number which represents our slope. I'll call it a, but really, I probably should use m. And then absolute value of x minus something, and then plus something at the end. This is a general form for an absolute value function that we've used in other books. Our book doesn't have it, but we've used that in other books as math teachers. So I need to identify A, H, and K. Well, HK is the vertex. So the vertex is right here, and the coordinates of that point are -3. And then I got 1, 2, 3, 4, 5, 6, 7. -3, 7. So I need my parent function vertex right here to go 3 left and 7 up. So how do I change absolute value of x so that it goes 3 left and 7 up? Well, I do absolute value of x plus 3 does 3 left. See, h is my vertex we call hk. In this case, h is -3, so we're really doing x minus -3. That gives me x plus 3. But just think in terms of left-right, where you want to go. And on the end, I want to go 7 up. So just put in plus 7. Now I need to identify the slope. Let's see if I can do that. I know the vertex here, -3, 7. Can I find another point on there? This one here looks good. That looks like a good point. So how do I get from this one up here to this one down here? I go down 1, 2, 3, 4, and right 1, 2, 3. What's down 4 and right 3? That's a slope. Down goes on top, -4, rise over run. 3 goes on the bottom. That's the equation of that function. Thank you for watching. Have a great day.